CC, GCC, and CLANG, three tools I am having, which will be the best in terms of cost optimization. The ongoing project will be hosted on European data center. The estimated cost would be around £1,000. So if there is any optimization scope, just selecting a good one like 5% or 10%, it would be huge in terms of savings. I had to take the decision which compiler to use for that reason. If I was the project manager, I would have choose Rust or Go, but in this case, we'll have to stick to the C programming language, not even the C++. I tried some testing on Office, but it was quite hard to verify because all of the racks are having some kind of modified Linux, and I would have get a slice of that part. So I need bare bone hardware to test those specific scenarios. Even that case, I have searched for some LLMs. They provided me some contradictory results, but I'm not sure what should I choose. So I decided to invest and dedicate some time. Like in this system, let's check how it performs in terms of CPU, RAM, and kernel calling. I will take some data and compare which is the fastest and optimized tool to generate binary code. And I have decided to do the test on different systems on bare metal. Like right now I am having three systems. One is based on GoPOS, you can say variant of Arch and NixOS. And I have FreeBSD, and I have a system with Alpine Linux. Alpine Linux on hardware. It is not virtualized. So I am hoping to get a better clear result so that it helps me to decide which tool to use, whether it is CC, GCC or CLANG. For that reason, I need some kind of C program to test. Like here, if I say this is the program to test the CPU, I thought in my mind, like I find calculating the prime number would be the best, but there are several ways to calculate the prime numbers. I have sticked with this one, but I will comment out the printout to the terminal because I don't want to mess up with the IO. There are several other algorithms are also there to identify prime numbers, but those are quite optimized. See, I don't want optimized code for this test. Let's quit and open a program that I have finalized. This one. Let me go through the functions first. This is the main function. All those results will be saved in a CSV file so that I can compare those later on. First, I will do the CPU test. It will print out those results in that CSV file. Later on, it will do the memory test, then flash. Each and every test, I have done some sleeping. That's because I want to make sure the system is getting enough rest for the next test. Then it will call some syscall for the kernel itself. Then it will spit out those results into the CSV file. That is the finalized code. For the memory test, I have decided to stick with this program, and for the CPU test, just the simple prime calculations. There is a defined compiler name as default unknown. Later on, this will be replaced by the makefile, and I have decided to use POSIX source code as 2008 version 9L. Let's quit over here and let me show you the makefile, how the makefile is written over here. I have decided to use this makefile as it will be easier for me to test all those testing scenarios in this system, that FreeBSD system, and the Alpine Linux one, so that it becomes less time consuming. I have decided to give some flags O3 and match pipe. There will be two files. One is runtime and another is compile time. It will check CC, it will check GCC and CLANG. If I type all, it will first make a clean. What clean does, it will just simply remove CSV files. Those are the codes. Let's execute make all. It may take a while to generate the CSV file. I think it is taking quite a bit long time as this is a simple laptop having mobile CPU. So it may take a while to calculate those calculations. Meanwhile, let's take those codes into my other systems. Let's remove all those files. make directory cc gcc and CLANG. Make file is done. Benchmark.c. Let's copy the benchmark C into the Alpine system. The Alpine system is having those needed files. Yes, I'm having those needed files. Before that, let's make sure if the Alpine Linux is having CC. Yes, it is having CC. If it is having GCC, yes, it is having GCC. Now let's see if it is having CLANG. CLANG is not present. For that reason, I'll have to install CLANG. Let's become the root. Incorrect password. Yes, I'm root now. pkg. No, it is having apk add CLANG. Let's hope for the best, and yes, it is installing CLANG. In that time, I could have copied those things into the FreeBSD. Let me see. First fetch is not here. htop is here. Which system is this? pkg. I'll have to be root first. pkg add first fetch. Oh, the installation command is install. First fetch is installable within FreeBSD. Let's install the first fetch. I see this is the system having FreeBSD, so this is a big confirmation, like I'm having first fetch. Now let's exit and become a normal user. cdp cc gcc and CLANG. CLANG means the LLVM. Now we are in the right folder or path. Let's copy that thing and micro makefile. Okay, benchmark.c. Now we are having those needed files. First fetch. So we are ready with all those necessary codes on Linux, on FreeBSD, and on Alpine Linux. So I can test all those operating systems. That is because Alpine Linux is having different implementation for those tools. General Pacman and Nix packages are having similar or nearly identical tools, especially for the Linux environment. And for the FreeBSD, it is totally different. So I expect some different output. That is the reason why I have choose those three operating systems. And I see on Linux it is done. In FreeBSD, there if I type make all, I will get some errors. That is because on FreeBSD, the make is also different. So I need gmake all. Let's proceed with this test. In the meantime, exit from the root user on the Alpine Linux and make. Okay, I see make is not present. If I type make, it says unknown command. So I'll have to install it. And the command would be apk add make. I think this is it. Permission denied. I'll have to be sudo user pkg add make. And this make should be GNU make. Yes. So this make and make on my machine, which is provided by Nix package manager, is the same. Let's exit the root user, make all. Okay, let it get processed, and it's time to see the result, runtime result. Okay, result is there. I see CPU is 109401 for CC. What a good option. And 107363. There is a good difference. More than 2000 point difference is there. So GCC is far ahead. What about CLANG? CLANG I see little closer to the CC, but still somehow manages to beat the CC. I wish I had those numbers in a bar chart kind of thing so that it would be visually more understandable. Okay, let's get those memory things. In terms of memory, let me increase the font size. In case of memory, it is 1.044 for CC, 1.044. And what about GCC? 1.18. So it means in terms of memory, it loses the battle with CC. What about CLANG? 1.03. CLANG outperforms both the GCC and CC. So if our application is memory intensive, it would be a better choice if I choose FreeBSD. Let's see other reports. what is the runtime report for what is this system is? This system is Arch and Nix based system, that is Gopi OS. That means this is some kind of pure Linux. And let's try to see the results in terms of CC 0281. In terms of GCC lost in a very bad way. What about CLANG 0.18? So I see the CC is the clear winner on generic Linux. As you see, this is 0.179757 and for CLANG it is 0.18. So CC beats GCC and CLANG in terms of CPU. Let's see about memory usage. For memory it is 0.3652. For CLANG, for GPU, for memory it is 0.18. In terms of memory usage, GCC beats each and every one. No, as I see, in terms of memory usage, CC beats them all, but very marginal way. What about syscall? I forgot to see those syscall reports. For syscall, it is 1.43. For syscall using CC is 1.431. For the syscall on GCC, it is 1.51. And for the syscall using CLANG, it is 1.57. So each and every times I expected GCC to win because it is the long tested and widely used one. By the way, CLANG, that means the LLVM. I understand CLANG is provided by the LLVM. LLVM is backed by various big tech companies, and I have expected like whether it will win this GCC or CLANG. I expected CLANG to be the way forward and much ahead of others. But each and every time CC wins. On FreeBSD, syscall is 10. In conclusion, my results are literally confusing and complicated. I cannot declare anyone as a clear winner. Managers are quite capable to handle those types of data and they will be able to create a visual chart. GNU plot is a good tool to create visual diagram like Windows Excel or LibreOffice Excel type. I'm not sure how to use GNU plot. Okay, let me grab those data and push it to our code. And it's better to have those codes freely available on like GitHub or something else so that everyone can take a look and decide by their own, and our managers will be take care for the decision they take. So that's for it. Oh, major mistake I have done. Just I have realized like I have done a major mistake because Zig provides a C compiler, and I remember Zig outperforms C, the programming language, in terms of performance multitude way in various practical use cases. So it's better to check the Zig CC compiler also. My pronunciation is not good. It should be Zig or something like that. The spelling is ZIG. Someone says ZIG. I'm not sure. ZIG. Jig should be the perfect or something like that. Okay, whatever the case is, I should have tried with Zig. I'm not sure Zig is available on the FreeBSD or not. Let's try to install a Zig over here. Let's be root pkg install Zig. Yes, Zig is installable on FreeBSD, so I should have taken Zig also in this comparison. I'm getting late. Let's see you tomorrow. Before that, let's push this code into GitHub. I don't think anyone should have any issue if I push those results into GitHub. Let's create a new repository. Let's name these as CC GCC CLANG. CC versus GCC versus CLANG. Performance in terms of hosting budget. The visibility should be public. I don't want to add a readme right now. Okay, let me get that repo. Git init, git remote add origin. Let's call it GH for GitHub because I'll have to put this on our Silicon Git also. So it should not be called as origin followed by the repo git add git. Okay, what if I take the full folder and later on adding multiple verses and later on adding multiple comparisons in that same repo? It would be much better. So please let me remove the git folder. Let's get previous folder benchmark. I would like to have a benchmark folder so that later on I can add other benchmarks to this folder or directory. Git init, git remote, git commit. It is an initialization, so it must be init untracked files. Oh, I'll have to put git add first. Git add, then git commit, push gh main. I don't have a main. Nowadays, I have seen like people are dropping the master branch that because someone thinks like master and slave should not be there. There was a time we had to choose hard drive, even cd drives, one as a master, another as a slave. Nowadays we cannot choose a simple git repo as a main or master. It is publicly visible. Let me see. This is the repo. Let me know if anyone finds a better way to compare those in terms of hosting expenses so that it becomes easier to decide. Goodbye for today. See you another day.